All right, so now to do some logical reasoning. So this is Prep Test 75, Section 3, and that's based on Law Hub, which I'm in right now, sharing with you, not based on the like PDFs or the prep test books. Anyways, so it's the second logical reasoning section, and question 17, it is a necessary assumption question. How do I know? It has the word requires and assumption. So why do I care that it's a necessary assumption question? Well, one of the reasons is because I'm allowed to use the negation test. So if you negate the correct answer choice, argument will crumble. All right, and what does it mean to negate? Okay, so when I negate something, I say it is not the case. All right, so negate true. So if I say that that answer choice is not true, right, then the argument will crumble. Negating something does not mean that we're saying the opposite is true. Okay. So, for example, now we have increasing and we have not increasing, right? The negation of increasing isn't decreasing, right? So if something is not increasing, it includes the possibility that it's staying the same or that it's decreasing. But if I just said that the negation of increasing is decreasing, I would be ignoring the possibility that it stays the same. All right. So that's something to keep in mind, right? Not A doesn't necessarily mean B is true. It just means A is not true. Maybe B is also not true, right? And maybe those aren't the only two options. If we do actually have just two options, like a true dichotomy, where it is either X or Y, there are no other options, then not X is the same as saying Y. Okay, but there are a lot of things that are not truly dichotomies. Okay, so with increasing and decreasing, that's not a true dichotomy because there's the potential that it stays the same, unless we rule that out. All right, so that's my little kind of side path in the realm of negation. So let's get into the stimulus. Maybe we'll do some highlighting here. So rocket engines are most effective when exhaust gases escape from their nozzles at the same pressure as the surrounding atmosphere. So that's when they're most effective. At low altitudes, where atmospheric pressure is high, this effect is best produced by a short nozzle. So at low altitudes, we want short, but when the rocket passes through the thin upper atmosphere, a long nozzle becomes more effective. Right, so depends where the rocket is as it's like going upward, right? Thus, to work most effectively through their ascents, all rockets must have both short and long nozzles. A long nozzle becomes more effective. So this would mean that the rocket has to be going that high, I guess, right? Like to actually pass through the thin upper atmosphere, and also it would have to start at a low altitude, I guess. It would have to do both of these things in order to be most effective with both a short and long nozzle. Alrighty. So that's kind of my idea of what I would need. Like that would need to be true, and if it doesn't actually have to pass through one of those areas, then it doesn't need either a short or a long nozzle. But there are lots of other things that maybe would be necessary to make this argument work. So as we go through the answer choices, we're thinking about, like, do I need this to be true? And then if we really want to test it, we want to see, well, if this isn't true, what happens? Does the argument actually crumble? All right. A, equipping a rocket's engines with both short and long nozzles is not significantly more difficult. Now, the difficulty of it is not really the issue, right? The condition here is what is going to make it work most effectively. That's what we're trying to reach, right? That's the goal, to work most effectively. Whether it's difficult to do it or not, like, the ease of making that happen is irrelevant to the question of what would be the most effective outcome. Okay, so that has to be eliminated. That if it's irrelevant, it can't be something the argument actually requires, right? Whether that's true or not isn't going to impact the argument. B, at some point during their ascents, all rockets will pass through the thin upper atmosphere. This is basically what I was predicting there as something that we're going to need. So if this isn't true, right, if some rockets don't actually pass through the thin upper atmosphere, then why would all rockets need to have long nozzles? The long nozzle is only necessary to create this most effective scenario when the rocket passes through the thin upper atmosphere. If it doesn't do that, then we don't care. Also, note that I did negate this by saying, what if some don't, rather than what if all do not, like if none do. So the negation of all is some. Okay, at some point during their ascents, all rockets will pass through the thin upper atmosphere. The reason that needs to be true is because the conclusion here says all, right? This isn't a very, like, medium kind of language here. It's like quite extreme language. And so that's why we do actually have to have all of them. And if we have an exception, then we can't come to the conclusion that all of them must have both of these things, right? So any exception to that is actually going to crumble the argument because the conclusion of the argument is so extreme. Okay. C, a rocket with only short nozzles on its engines can't reach high altitudes. I mean, yeah, like that kind of helps the argument here potentially, but what if that's not true? What if one with short nozzles still could reach high altitudes? Well, that is possible to coexist with this argument, right? So the negation of C could possibly coexist with this argument. Just because something is possible that they could still reach high altitudes doesn't mean that they are going to be most effective at when they get to high altitudes, right? So we're looking for optimizing, not just making it possible. D, for a rocket to work effectively, its engine exhaust gases must leave the nozzles at the same pressure as the surrounding atmosphere throughout the rocket's ascent. So this is kind of just adding the throughout the rocket's ascent part. So what if it didn't need to do that throughout the ascent? What if it only needed to do that for part of the ascent? That's interesting. Exhaust gases escape from their nozzles at the same. For a rocket to work effectively. So here we don't have optimal, we just have effective, not most effective. So this doesn't actually need to be true either, because it's actually kind of yeah, let's see. Okay, so for a rocket to work effectively, this must happen. I think the difference between most effective and just effective is enough for me to eliminate D. Otherwise, D looks actually appealing because they add that throughout the ascent part. And what if it only part of the ascent it needs that? For a rocket to work most effectively at both low and high atmospheric pressures, it must have at least one engine that has both a short and long nozzle. Okay, cool. Still, is that necessary for rocket? Does that need to be true in order for the argument to be true? I would kind of say that really what it comes down to for me is if they don't, like if B isn't true, then it doesn't matter whether E is true or not either, right? Like it's just everything crumbles if throughout their ascents, they actually don't pass through the thin upper atmosphere, because then we don't care about the long nozzle at all. And the high and low atmospheric pressure thing becomes irrelevant as well. So yeah, I'm liking B here. B just clicks really nicely for me. And that's kind of a tough thing. I hate saying that because of course, why does it click really nicely? Well, I mean, because has to be a reason, right? There has to be something I can communicate about my process for this question that allows you to choose B rather than E. And rocket to work most effectively at both low and high atmospheric pressures, it must have at least. This one, is kind of a restatement of the conclusion, though. Like, it just seems like a bit much. Yeah, this too, like, to say that on their engines they have to have short nozzles and long nozzles doesn't mean that a single engine has to have both on it, right? Like we could have some engines that have the short and some that have the long, and we switch to a different engine. And so we would never have any single engine that actually has both on it. We could have dedicated short nozzle engines and dedicated long nozzle engines. So that would be why E doesn't need to be true. Okay, so if I can negate E and it's still, and the argument still work. Negating E doesn't actually make the argument crumble. That's why E is wrong, because there's a way to negate that, and we aren't like disconnecting a premise from the conclusion. Whereas with B, if we negate it, we are disconnecting the premise, which is, when a rocket passes through the thin upper atmosphere, a long nozzle becomes more effective. Disconnecting that from the conclusion, which is that therefore all rockets have to have short and long nozzles, right? So if they don't need, if they don't go through the thin upper atmosphere, why would they need the long nozzle? That it just completely disconnects there. Whereas E, I can think of a potential scenario, where you would have long and short, but you don't have any single engine that has both at the same time. You just have multiple engines. Yeah. Okay. So definitely like a tough question, I would say. And the answer is B. That is the one that needs to be true. Yeah, for this one, I mean, if you If you're going by how stream the language is, then I think B is a bit of a tough sell because it has the word all in it. But of course, because the conclusion is extreme, you kind of need that extreme language in order to make it work. So ultimately, going by that guideline of strong language, weak language is only going to get you so far. There's still some questions where you're going to miss that. And even, going through them this way, it took me a while to really see what was wrong with E. So yeah, and I mean, like I said, I had that feeling about B where it clicked for me that this really, and I think it's because of that thing of we're really disconnecting a premise from the conclusion, whereas E, it was like they're just kind of restating what the conclusion says, but then adding this like it has to be a single engine, like it didn't. I was like, oh, I don't really like that. Just the whereas when I read B, it was like, boom, that's the way to do it. So it's like exploiting the fact that they never actually told us that all rockets have to go through both of these altitudes during their ascent. Yeah. Okay. So yeah, like I said, this one is a tough one, and took me a bit longer to really process like the reasoning that was sort of underlying my my decision there. So hopefully that makes more sense now. But yeah, I definitely went all over the place on that one. But hopefully that helps a bit, like, continuing with these necessary assumption questions. Necessary assumption questions, like sometimes you will get an easy one, but I do find that they tend to be a bit harder, and like assumption questions in general are often a type that students struggle with. They do require a bit of a deeper analysis, I think, than some other question types. So keep plugging away. It does get easier, and apparently for me, it's gotten to the point where I don't even really know why an answer looks good. It's just like, oh, that gives me that good feeling, that good, like, I'm in the LSAT writer's head sort of feeling. Alrighty, I'll leave you with that. I've rambled on long enough. If I can actually get out of here, and there we go. Okay. Talk to you later.